Alright, problem number 2. We're given the equations z, plural, because it's plus or minus, notice that there. But anyways, we're given the equations of the asymptotes, which means this is a hyperbola. We're also given the foci. Notice I say foci, even though it looks like there's only one focus shown. Notice again the plus or minus there. Now that's actually pretty useful the way this is written because we can learn a lot just from these two little pieces of information. For example, notice the way the foci are written. The x value is the same and the y values are changing. The whole plus or minus there, that tells you that this is going to be a vertically opening hyperbola. Furthermore, it tells us that our focus is at the point -4, 3, because I don't know what I just said. I meant to say the center is at the point -4, 3, because the foci are going to be a distance of c away from the center, and that's essentially what that 3 plus or minus root 5 is saying. It's saying the foci is root 5 away from the center in up and down. So let's go ahead and show that. Now we can also go ahead and plot our two foci as well. Square root of 5 is roughly 2.2, 2.3. So we want to go from 3 up a little over 2 and down a little over 2. So that's going to put us up a little bit above 5 and then also a little bit below 1 right there. So we've got our two foci and our center, and also recognize that we can get our center from those values as well. And now let's think about how we can get our A value and our B value, because we already know our C value. We know our C value is the square root of 5. So remember that the slope of the equation of the asymptotes is in the form either b over a or a over b. Now in this case it is going to be in the form of a over b because slope is rise over run, and this is a vertically opening hyperbola, so our a value is going up and down, meaning that is our rise, meaning it has to be our numerator. So for b over a, we're going to have 2 over 1. So b is 2 and a is 1. And check it, make sure it's not some other similar ratio like 4 over 2, so 4 for b and 2 for a, because remember, since this is a hyperbola, we have to have c squared equals a squared plus b squared. Well, c is the square root of 5, so c squared is 5, equals a is 1, 1 squared is 1, plus b squared, b is 2, so we get 4, and so it works. So it's not going to be some other a and b value that fit that ratio of 2 over 1. So what does that tell us? Well, we know a and we know b, so we can draw in our little box. So up and down we're going to go 2. That's already marked by our foci. Sorry if it sounded like I was really flustered for a moment. It was because I was really flustered for a moment, because it's 10 o'clock and I'm getting tired, and I was confused because it looked for a moment like our foci were where our vertices should be, but actually they're not, because remember, the foci was a little bit above 5 and our vertices actually at 5. And similarly here, our foci was a little bit below 1, and here we are actually at 1. So it's like that, because remember, c is square root of 5, which is 2.25-ish, or wait, no, 2.23-ish, And our A value is 1. So I actually realized I just messed up again. So our A value is 1, so that means that our vertices are there and there. My bad, guys, I'm messing this up. And our B value is 2, so that means I'm going to go 2 to the right of our center, boop, and 2 to the left of our center. And now I'm going to draw in that box. Mine doesn't look very good, but it looks good enough to go ahead and draw in those asymptotes. And again, it's hard to do this on the iPad, so please make yours look a little bit better than this. And now finally, we can sketch in that graph, and I'm going to make it look as good as I can, but no promises here. But hey, at least I've got colors. That's kind of cool. But there we go, and I think we're not quite done yet because we need to write both equations. So in rectangular form, it's nice and quick. First off, since this is a vertically opening hyperbola, we know that the y term is going to be squared. And by squared, I mean we know the y term is going to be the positive term. So we're going to get y minus 3, quantity squared, over our a value, which is 1, so over 1 squared, minus the quantity x plus 4 squared, over our b value, which is 2 squared, equals 1. And make sure you recognize y minus 3, x plus 4, x plus 4. That's nice. Okay, and now we want to do this in parametric mode as well. So x equals and y equals. First off, remember it's going to be tangent and secant. And that's, again, coming from our Pythagorean identities, so you can prove that to yourself if you don't remember. And now I like to remember that tangent is the negative one, so tangent in this case is going to go with x. So I'm going to get 2 tan of t, and that's going to be minus 4 equals y is going to be y equals 1, so you don't really need it, so I'm not going to write it, and it's going to be secant of t, and it's going to be plus 3. And that's going to be 0 less than or equal to t less than or equal to 2 pi. And I have to apologize because I realize I just made a mistake. Jump back to when we were talking about the slope, that 2. I said b over a for some moronic reason. This should be in the form a over b. Why do you ask? Well, because it's a vertically opening parabola, and a is always going to be going between your two vertices. So that bit right there would be a, that whole thing would be 2a. So I messed that up. That means that this needs to be in the form 2 over 1 equals a over b. So a has to be 2. And b has to be 1, which changes a couple things. It means that we need to change both of our equations. Instead of a 1 squared underneath y, we need a 2 squared there, and we need to make the 2 squared underneath the x a 1 squared. Similarly, in our parametric equation, we need to change the 2 down to be with secant. That should fix everything. Sorry about that. Hopefully you caught it yourself, but if not, make sure you made that change now.